Okay, working with other types of equations. First, we're going to look at absolute value equations. Reminder that the definition of absolute value is basically the distance a number is from 0. So if C is a positive number, then the absolute value of C is just C. Okay? So if C is 45, so if I have the absolute value of 45, it is 45. If C is a negative number, okay, absolute value of negative 23, then that's equal to 23, right? So if C is negative, then the absolute value of C is the opposite of C, right? Okay. Because if C is a negative number, if C equals negative 23, the absolute value of negative 23 is equal to 23, which is the opposite of that number. Okay? Now, the reason that it's important that you understand that definition is that not always are the numbers we work with so cut and dry. Because we may have absolute value of pi minus 6 maybe. Okay? Start working with irrational numbers. And if I have the absolute value of pi minus 6, well, think about it for a second. Is pi minus 6 a positive number? No, because 3.14 minus 6 is negative. So then if I have the absolute value of pi minus 6, then the absolute value of that is actually the opposite of pi minus 6, and you would get 6 minus pi. Okay? Because the signs would change when we do the opposite. So we do the opposite of that. Okay? So when we're solving absolute value equations, you have to remember the fact that I could get a positive answer and I could get a negative answer. So the absolute value of x minus 3 be that x minus 3 could equal 5, or x minus 3 could equal negative 5. So we have two equations we have to solve. So x would equal 8 or negative 2. And one thing to always remember when you're solving absolute value equations, or any equations, because we will be looking at absolute value, we'll be looking at radical equations, is that your first step you're always going to want to do is make sure that you isolate that absolute value or that radical. So if there's anything else on the same side of that equal sign with that, to solve those equations, we want to move all the other stuff the other side. Okay? So let me just reiterate that for a second before I go on here. So if, for instance, if I would have had, in this case here, if it would have said the absolute value of x minus 3 plus 2 equals 5, okay, my first step here would be to subtract the 2. Because before I can do the plus or minus, the absolute value must be by itself on the one side. Okay? Okay. Now, reminder that when you solve equations, it's very important that you check your solutions to make sure they work. And quite often when we're working with absolute value and working with radical equations, we have extraneous solutions. Who can remember what an extraneous solution is? Sam? Okay, so it's an answer that we get when we solve it, but in reality it doesn't, it's not correct because it doesn't fit the equation. So we have to be careful and make sure that we check all of our answers. So here we want to solve this equation. Absolute value of x plus 3 equals 4x minus 1. So either x plus 3 then could equal 4x minus 1, or x plus 3 equals the opposite of that. Let's leave that picture there. All right, we'll show it here with a. So I just want you to, since I've got it there already, look at the graph here. If we graphed this, here's the absolute value of x plus 3, okay, and here's the line 4x minus 1. We can see that they only intersect in one spot. So it's very important we check our answers to make sure. Now, it's a very simple process at the end, and I'll show you that when we get there. Okay, so let's solve both equations. So we're going to solve this like we normally would. Subtract x and add 1 to both sides. So we get one answer is 4/3. Solve the other one. So we distribute the negative. So we're going to add 4x and subtract 3 in this case. So the two answers that we get solving those equations are 4/3 and -2/5. Well, the question is this. Okay. If I take the absolute value of a number, what is it always going to be? Positive. The absolute value is always going to be positive. So all I need to do is look at the right-hand side. Okay? I don't even need to concern myself with the left-hand side. Okay? If I put 4/3 in there for x, will I get a positive number? 4/3 times 4 minus 1. Is that a positive number? Yes, it is. Okay? If I put this negative number 2/5 in here, 4 times -2/5 minus 1, is that a positive number? No, it's a negative number since it's, and I can't do the absolute value of a negative, so that answer does not exist, and 4/3 would be the only one that works. And we can see from this graph then, if I put in -2/5, -2/5 is over here. Okay, it's about -2/5 is about here, right? And we can see it at that spot that on the line y, 4x minus 1, it's down here, and the absolute value 1, it's up here. So those are definitely not at the same spot. And that's what will happen is whenever you have an extraneous solution, that it just won't hit both graphs at the same spot then. And like I told you yesterday, that this is actually a problem that if you couldn't remember, okay, how to do it, I can just put both sides of my y equals, or do absolute value of x plus 3 minus 4x plus 1 equals 0 and find the zeros. Okay? And you would only find 1 then. Okay. All right, so another absolute value one. This one's got a quadratic. So 3x squared plus 6x minus 1 could equal 1. Or 3x squared plus 6x minus 1 equals negative 1. Maybe. Let's see. So we have a quadratic. What are you supposed to do when you have quadratic equations? Okay, hopefully we can factor, right? But to do that, I've got to get it by itself. Thank you there, resting person. So we subtract 1 from both sides here. So we want it to be equal to 0. So I'm going to do the right one first because that's just easier. So one on the right side, I can factor out 3x. So x equals 0 or negative 2. Right. Can we factor the right-hand side? No? Because 3 times 2 is 6, and if I subtract 1, I get 5, right? Okay. So what are we going to have to do? We're going to either have to use the quadratic formula or complete the square. Well, we can't slide and divide because it can't be factored. You could try to slide and divide, but there's no factors of 6 that add up to 6. That's the problem. Okay. So when I'm thinking about factoring, if I multiply 3 times negative 2, I get negative 6. But when I take factors of negative 6, I either get 5 or 7, okay, or 1. And so they don't add up to 6. So we would have to use the quadratic formula here. So let's do that. Now, I want to emphasize something because this reminded me of something on the quiz. Okay? Those of you who decided to just use a single fraction bar, there was a couple of you then that basically ignored the fact that the denominator goes for both parts of it. Okay, and that's one of the reasons why when I write the quadratic formula, I write as 2 separate parts, so I don't forget that the denominator goes with both pieces. Okay, so if you had some points off on that quiz on that problem with the quadratic formula, part of it might have been because your denominator, you didn't use that to simplify both parts of the numerator. Okay, so we're going to get negative 6 over 6 is negative 1. Plus or minus 36 plus 24 is 60. Okay. All right. So let's use, so in this case though, the right-hand side of our absolute value is just a number, and it's positive. So I can't just, oh, if that's negative, it's not going to work, can I? Okay. We would actually have to check each one of them, okay, to see if they would work. All right, so let's see. All right, let's go with the easy ones. 0. If I put 0 in here, 0 plus 0 minus 1, absolute value of that, is that equal to 1? Yes, okay, so 0 works. All right, so let me use red here. 0 works, we're good. Okay. If we square negative 2, we get, and 4 times 3 is 12. Okay. 6 times negative 2 is Okay, so 12 minus 12 is 0. Absolute value of negative 1 equals 1. Okay, so these two both work. All right, we're good there. Oh man, and I got these radicals. Okay, all right. So what should I do then? Type it into your calculator. Okay, and the only thing I need to type in my calculator is just do this. I don't even need to do the absolute value. All I need to do is if this is a true statement here to do it. Let's think about what these numbers are here for a second. Okay, all right. What's the square root of 60 approximately?
7.
Okay, so, but it's almost 8, right? Okay. So negative 1 plus 8 over 6, that's going to be a positive number, right? So a very small positive number. Negative 1 minus 8 over 6 is going to be a little more than negative 2, right? Okay. So for my window then, if I just hit my standard viewing window, zoom 6, should be able to see these. All right. Now, if I hit trace, so let's use our intelligence, I can do negative 1 minus, and you have a fraction bar, oops, minus, oh man, why wouldn't it do that? Okay, won't do it there. Square root of 60 divided by 6. Okay? And if this is an answer, then it's going to be right there, right? Okay, enter. Yep, there it is. Okay. Negative 1 plus square root of 60 divided by 6. And hey, look at that. Okay, all 4 of them work. Now, problem like this, I would expect that you have this answer here. I don't care if you simplify the square root of 60 or not. Okay, 2 square root of 15, that's up to you. Okay, but I don't want to see a decimal. That's what I'm saying. All right, I think we got one more to do. Solving radical equations. Okay, like I said, first of all, or when we were talking there about the absolute value, that I always want to make sure I isolate the absolute value or the radical. Okay, if both sides of an equation are raised to the same positive integer power, then every solution of the original equation is a solution of the new equation. So when we square it or cube it or whatever we need to do, all right, we're still good with that. All right, so this is the one in the book, and so I'm going to do this one for you first. Okay. So the first thing we're going to do is subtract 5, because we want to get the radical by itself. Now, there's one particular skill about not factoring but foiling that if you can pick this one up, it'll make life a whole lot easier for you and allow you to do calculations much faster. And when we're talking about perfect square trinomials, I just want to remind you of something, that if I have a plus b squared, okay, that is equal to a squared plus 2ab plus b squared. Now, what's important about that is the fact that if you use that instead of every time I see a plus b squared foiling it out, it'll make your life a whole lot easier. Okay? So with this problem then, I have to get rid of the radical, so I'm going to square both sides. And this is where the perfect square trinomials come into play for you, is that instead of having to do x minus 5 times x minus 5, I know that it's a squared, plus 2 times ab. So when I multiply x and negative 5, what do I get? Okay, I get negative 5x, and when I double that, I get negative 10x. And then plus 25. So if you use this fact over here, all right, whenever you are squaring something, it'll make life a lot easier for you instead of having to always multiply it out. Okay, so all I do is first thing squared, double 5, and I get 10. Square 5, I get 25. Okay, there's that completing the square thing too. Okay, all that goes together. So now, when I solve this, I need to get rid of the 3x and the 11 because we have a quadratic. So we want to get everything on the same side so I can have it equal to 0. And then hopefully it's a problem that I can factor easily. And this one is, what are the factors of 36 that add up to 13? 4 and 9, right? So we would get that x equals 4 and 9. Okay. What do I need to do now? Okay. All right. Now, let's think about this. Here's our problem here. Oops. If I take 5 plus a number, am I going to get 4? No. Okay. Can this radical ever be a negative number? Because it couldn't be 5 minus 1, could it? It could be 5 plus 1, but not 5 minus 1. So 4 cannot be a solution because 5 plus any number is going to be greater than 4. So my only answer is 9. The x equals 9. Okay? So there we have an extraneous solution again. So you need to check them. And that's an easy check. Okay? Because here, this number is 5 here. If I add anything to 5, I'm going to get a number bigger than 5. So if I get an answer that's less than 5, it don't work. Okay? All right. So we're going to subtract x. So we get the square root of 4x plus 33 equals 2x plus 1, or minus 1. Okay. We square both sides. So we get 4x plus 33 equals 4x squared double the product of these. So 2x times 1 is 2x, times 2 is 4x, and plus 1. Okay. So we're going to subtract 4x and subtract 33. So we get 0 equals 4x squared. Negative 4x minus 4x is negative 8x. And 1 minus 33 is negative 32. Find your mistake then, Rachel? Okay. All right. So I can divide everything by 4. Now I was looking at Turner's and he factored out 4, and that's fine. But in this case, I could divide by 4 and it just gets rid of it, doesn't it? Okay. Because 0 divided by 4 is 0. Oops. So 0 is equal to x squared minus 2x minus 8. So we get x minus 4 and x plus 2. So x equals 4 or negative 2. And if I go back to the original, if I put negative 2 in there for x, I get a negative number. And 1 plus a square root cannot be a negative number. So negative 2 is extraneous. And my answer is just x equals 4.